Hi everyone, thank you for joining us. Can you listen to me? Hello? Okay, so today's webinar is with Vipul Kocher, the soul and founder of TIE, spelled as TESTAING.com, Verity Software and Salt. He also chairs the Indian Testing Board of ISTQB and has invested testing techniques like Q patterns and the linguistic analysis techniques for test design and reuse. As is our topic today, we will be discussing testing and AI. Who better than Vipul? He has founded TIE that focuses on training and mentoring people to test AI products efficiently and effectively. So we will start. If you have any questions, please use the Q&A section at the bottom of your Zoom window. We can answer them towards the end of the session. Over to you, sir.
All right, thank you so much. So, welcome all. Namaskar. I hope all of you can see me. Interestingly, in this whole panel, I can't see my own video. So, I don't know whether my head is being cut off or whatever, but I guess everything's okay because you are not here to see me, but to see the presentation. So it should be all good. Today, we are going to be talking about AI and testing. And it's a very interesting concept, the whole AI thing, because it seems to be taking the world by force in last few years. So it's very topical, and I would like to thank Testsigma for arranging this webinar so that we could converse. What we are going to talk about today is going to be a little bit on what is AI. A lot of people have heard AI and machine learning. So our focus would be on AI, machine learning, distinguishing between the two, and then showing what actually machine learning is, how does it happen, and so on. In this due course of time, we will also talk about how to test AI applications. We are going to talk about many other things. But some rules of the engagement. If you have any questions, I would be happy to answer them. Feel free to write them in the Q&A, not in the chat window, because in chat it's difficult. Everybody can respond to it and so on. But QA, if you put your questions in the Q&A, then I would be able to look at them very easily and would be happy to answer all of them. Ideally, I would like to take the questions towards the end. However, I understand that on a given topic, you may have some questions. So I will keep looking at the Q&A window. And if you have any relevant question that has to be answered, then in there, I will pick that up. Hope that makes sense. And I also hope that you are able to see my presentation. So if you are able to, then just say yes, and that should be good enough. All right. So shall we begin? Let's see what's the time. 3:36. So we are 6 minutes past, and so good enough for us to start the presentation proper. I run a company called Verity Software, which is a training company. I'm one of the co-authors of AI United, the world's first AI testing, so AI and testing certification. And I also run Step-in Forum, not-for-profit organization, which is testers community with chapters in 7-8 different cities in India, organizing conferences in 4 or 5 of them. We are probably one of the biggest testers communities in the world, with so many chapters, and people from the industry, they get together, share knowledge as evening talks, webinars, actual conferences, and so on. So if you are interested in sharing your knowledge, or if you are interested in listening to other people share their knowledge and do things and so on, Step-in Forum is the thing to look out for. Okay, so If you want to reach out, you know, uh, these are various handles, and both for Testsigma and the companies that I run, and also for AI United. If you want to connect with me, you can connect with me on these email IDs. Um, a few of the email IDs that I have far too many, um, but don't worry about the spelling in the first one. There's no spelling mistake there. You can also connect with me on LinkedIn on Vipul Kocher, one word. Should be able to find me there. If you want to know anything about AI United, for example, you can contact Vinay, whose number and email they are given here. And of course, if you want to contact Testsigma, on the previous screen, I've already shown you their handle. So let's begin. From an agenda point of view, what is it that we are going to cover today? I have already talked a little bit about that, about what is AI and what exactly is machine learning, the difference and similarities. What I didn't say at that time, which I'm saying now, is that we will also do some hands-on stuff where we will create some model, and then we will see what is the machine learning life cycle all about. And then, how do you test AI applications, and where in the whole life cycle of machine learning testing comes in? What are the challenges of testing AI applications? And what are new things that you need to learn to know more about testing AI applications? We are also going to talk a little bit about AI and explainability and ethics and so on and so forth. And finally, we will talk about AI for testing. How can you use AI in testing? How can you make use of AI in SDLC, for example, or for doing better testing or for automation? So this is the agenda. I hope to cover it in quarter to 2 hours, maybe a little less than that. And then, the remaining time, we are going to be talking about questions. So basically, I'll be trying to answer the questions. There are a number of certifications I have participated in. Um, DevOps United is another certification that the United family has. I'm also one of the chair of mobile certification from ISTQB, Certified Mobile Application Tester, and I've been involved in many of the ISTQB certificate syllabuses and so on. What I'm going to show you today comes from a 3-day hands-on course. So this hands-on course is about AI, and in 3 days we covered the following things. We cover what is AI, ML, and so on, stages of ML process. I'm just going to give you an overview today, but the details of that can be looked at there. And then, what is offline testing? We do hands-on on various data processing steps. Don't worry what those are, because I'll explain all of those to you. Then we are going to talk about metrics, online testing, how do you evaluate different AI models. And again, don't worry, I will explain the model part as well. Then some technique that I have developed, which is very useful for AI testing. And then we talk about risks on the 3rd day. How can we use AI for testing? We do hands-on on automation for use for those tools that use AI in automation, and followed by a mock exam, followed by certification. So that's the overview of 3-day. I'm going to pick up some things from each of these days, and I'm going to talk about those things. So where are we with respect to AI? What is hype? What is reality? Is AI here already? Is AI here to stay? There are a lot of things. But first, let us talk about something interesting. Let us see something interesting. What you see on the screen is Denver Airport. And what you're going to see now is at the Denver Airport. So let's take a look at that. I hope you can hear also.
That's a little too close for comfort, lady. Oh, damn. What, you never seen a talking gargoyle before? Welcome to Illuminati headquarters. I mean, Denver International Airport.
This is awesome.
Hello? Do I know you?
Are you hungry?
Oh, I'm starving. You got anything for me? Those flowers look delicious.
Oh, it's because of the conspiracy.
Oh, it's because of the conspiracy. Look at me. I'm a little know-it-all. Will you get back over here? I got a question about this conspiracy. Did you have to buy an extra seat for your hat, sir? Sir, are you stealing a desk? Sir, you have resting, confused face. Do you have a favorite animal or pet?
A caterpillar?
A caterpillar? Wouldn't you rather have a gargoyle?
No.
Okay, guys, some of you, I would be happy if you respond to my question on the chat. Do you see any AI here? How do you think this works? Is there AI behind this robot? Yes, no would work. All right. So Ashi says, yes, of course, there is AI. Yes, when you say yes, I assume you're meaning AI is there. All right. Thank you, Arvind. All right. Of course, AI. Okay, before I come back to this, what do you see on your right-hand side? A $200 AI-enabled toothbrush. Now, that's a reality for sure, because this is selling in the market. I did a lot of search on trying to find out whether this gargoyle is actually AI. And there wasn't any concrete information available on the internet. There were speculations. But if you have seen Sophia, the robot who was given the lady, I use the word lady, the lady robot, which was given citizenship in Saudi Arabia, and she answers and speaks and so on. You would realize that the state of AI is not nowhere close to what this gargoyle was doing. Of course, you can have a microphone, you can have cameras, and you can capture sound and you can capture visuals. But then the AI system or whatever system is behind has to actually make sense of the sound. So there's natural language processing involved, or the visuals, which means vision systems. So whether it's a video or image doesn't really matter. And then you have to respond within a certain time frame so that it looks like real conversation. And then there is humor. There is a situational awareness. There is a contextual awareness. For example, Ramya said that, on the chat, that it recognizes facial expressions. Indeed. So first of all, recognizing a human being, recognizing facial expressions, recognizing sounds, making sense of them, and then give a contextual reply which has human elements in it, like sarcasm, like humor, and so on. AI, that's the holy grail. We want to be there. We are not still there, and we are not still there in many of these aspects, and also in terms of responding to things that quickly and so on. So clearly, that's neither hype nor reality. But what you see on right hand side, while it's bread and butter for the people who are selling it, but maybe you didn't really need machine learning and AI in the toothbrush. Maybe you did, maybe you didn't. So what I'm trying to say is, it's very interesting how everybody has jumped onto the bandwagon of AI, and everybody wants to have AI in their product. In fact, a survey said that 60 to 70% of the products that claim they have AI either do not have AI or have AI which is useless, meaning even if the AI were not there, it wouldn't make a difference. It's not really useful to the user. So that is where we are today. Now, the question that I have for you is, what is AI? Well, we are human beings. We have intelligence. Well, looking at many of us, it doesn't really appear we have intelligence. Looking at the war, the strife, and so on. Looking at poverty, It doesn't appear that we have intelligence. But assume for a moment everybody has intelligence. What does artificial intelligence mean? Machine should have human-like intelligence. Okay, so that is what people say AI is, where machine can perform functions which require intelligence when performed by human beings. All right, so that is AI. I would always request you to keep in mind that when the word human-like fashion or human intelligence is used, you would want to ask a question. Human beings are not the most rational beings there, meaning many of us are very irrational, or many of us are rational in some situations and irrational in other situations. So do we want AI to be like that? So, just using the word human as an attribute may not be good enough, but doesn't matter. For a moment, let's assume human beings are intelligent, all of us, rational beings, all of us, and machine that, requires these attributes to solve problems. So that is AI. I have not used the word machine learning yet, which I will a little later. So don't worry for the moment, the difference between AI and machine learning. Let's just focus only on AI. So in 2013, IBM started, it partnered with a cancer research institute, and it wanted to develop a cancer treatment program or a system which will help alleviate. And if such a machine is available, then you don't need super expert doctors. Chances are people can connect remotely, and then a lot of telemedicine can happen. Cancer care can be made affordable, and so on. So what better than artificial intelligence? Well, $62 million and 5 years down the line, it was shut down because it was giving wrong advice, dangerous advice. And it was not because of lack of expertise, either on the software side. IBM was there, Watson, which is a beautiful piece of software, is there, or advice from doctor's point of view, because Anderson Cancer Center was involved. Nor was money a problem. $62 million is a huge amount of money. And nor was time a problem, 5 years, but it didn't really achieve its goal. So clearly, there are some things for which we are not yet ready for AI to go prime time. But of course, recognizing human beings, recognizing cars and so on, it's such a common phenomena that really shouldn't be a problem. So because AI is being used there often. Let's watch this. So when you do image processing, you have something called as object identification. So you can see objects are being identified. So it's identifying chair, it's identifying human beings. So I guess these are two things that they are interested in identifying. Well, what about the second human being? He's actually clamoring for attention, and the system is not recognizing. Why is that so? Is he less of a human being? And what has happened now? Why does it recognize a human being now? Oh, that must be the picture that he's rotating. That doesn't seem like a particularly interesting picture. It seems, just a regular colored photograph. Now imagine it's an unsupervised, unattended security system. And this guy carries this kind of a token and is invisible to the system. And he has passed on the invisibility token to the other guy. That is very interesting. That means just a small picture and actually just a small set of pixels can fool some of the AI. If that is the case, we can't rely on AI too much, right? That's a problem. Anyway, these are two AI bloopers. There are many AI bloopers of this type available. It doesn't mean AI doesn't work. It means that we have to be careful in assuming what all it can do and what all it cannot do. So I hope that helps you understand the challenges of AI. Well, AI is nothing new, right from 50s when people wanted to create an artificial brain to 1980s when I was in my college, especially late 80s, and genetic algorithms, fuzzy logic, neural networks, they became very popular. My teachers who had just done masters went on to do PhD in neural networks and so on. And it appeared as if neural nets are the future. I was also asked by some people to enroll in PhD programs on using neural networks and so on, but I decided to go to the industry. Well, neural networks didn't go anywhere. Fuzzy logic, genetic algorithms, they all died their own death. And I was very happy, early 90s in my job in software industry. We would get hikes 2 times a year, sometimes 3 times a year, 100% hike over a year, year after year. Are you jealous? Well, those were the good old days. And they were really good old days because in 1 year, when I started, I was earning half the salary of what my father was earning 20 years later. And within a year, I was earning more than him. So that was very interesting. However, AI didn't go really anywhere. And then finally, some things happened that the AI became mainstream. What happened? Cloud happened, big data happened, machine learning frameworks happened. And with cloud came computing power. With cloud came resources. With cloud came storage. And big data, a lot of data related to a lot of things started getting accumulated. So when there was a lot of data, a lot of computing power, the potent combination was available, and now you could supply the data to the computing power to figure out or make sense of the data. And that was the evolution of machine learning. Now there are, so this was around 2010 to 12 when machine learning started to take hold. And 2015-16, machine learning became mainstream. Everybody started hearing the name machine learning and so on. And today, every part of your life or every day, you use machine learning right from morning to evening. You use AI morning to evening. Before I move on where you use it, and some of you may be aware, not aware, we need to look at AI. So there are typically 3 types of AI that people talk about. One is narrow AI. Narrow AI is like, you teach the machine to do one task and it does only that task. It cannot do any other task. So if you teach a machine to play game A, then it is very hard for the machine to play game B. If you teach the machine to play games, then the machine cannot, for example, cook food for you or prepare recipes or compose music and so on. So this is called as narrow AI. It's very narrowly focused. This AI is not intelligent even as a cockroach. Forget about a dog. So narrow AI is intelligent, but in a very narrow sense. Then comes the name general AI, where the AI can do multiple functions, can learn new things and retain old things and continue to diversify its learning and so on. This is the holy grail. Everybody wants general AI except the alarmists. And why don't they want general AI? I'll talk about it. So essentially what we are talking about is AI, which is like human being, which can learn, continue to learn new things, diverse tasks, and so on. And super AI is which is much more intelligent than human beings. And if you watched Terminator and so on, you would remember the big bad AI, super AI. So people are afraid of the singularity, that if that happens, then AI might wipe off humanity, or humanity might become slave to AI. There's other part of it like E.T. and this film, Hrithik Roshan, I forgot the name. Those are the kind of, well, actually there was no AI there, but there was another AI in one of the Hrithik Roshan's films. So we are talking about benign AI, bad AI, good AI, evil AI, but we are very far from general AI. Forget about super AI. We are not yet there. Having said that and having understood we are talking about narrow AI, let us move on to some more disambiguation. Okay. We talked of AI. So initially, what was AI? So expert systems became popular. Those were AI. Search and optimization problem. that was considered artificial intelligence. So AI was this big bucket which had these problems getting solved. But as I said, come the 21st century and big data and cloud and so on, you now use data, and you use data to discern patterns from the data. So when you use data and find out patterns within that data, that and then use those patterns to predict future, then that is machine learning. Now that's a very interesting thing. Typically what happens is, as programmers, you write code, you compile it, that's your software, and then you feed data to that software and the result comes out. So essentially, human being writes programs, the data is fed into it to get the output, and the data is something that is required for which you want to produce the output. Now machine learning turns the process on its head. Nobody writes a program. There's a pre-written program, somebody has written it, doesn't matter, it's a generic program, it's lying there, and you feed the data to it. When you feed the data, the output of that is a program. So now what you are getting after feeding data is these patterns that have been recognized, and let me use that, and these patterns would be used to predict the sense, the future of the data that you feed in, or the output based on the data that you then feed in. Now, what are we talking about here is that program generates program, or data generates program. So that is machine learning. So naturally, it's a subset of AI. And within machine learning, when you use neural networks, complex neural networks, more than 2 layers. So when you use 3 or more layers of neural network, where there are hidden layers, don't worry about what hidden layers are. This webinar is too short to explain in detail neural nets, but I'll try to explain a little bit. So deep learning is where you use a lot of data and neural nets to basically create a prediction model. That is deep learning. So naturally, it forms a small part of machine learning. So this is the whole AI landscape. I hope it helps you understand the difference between AI and machine learning. AI is the broader term. Machine learning is the narrower term. And deep learning, is still narrower. Now, interesting thing is, what was AI in 1950s is no longer AI. Whatever was AI in 1980s may no longer be AI. And whatever is considered AI today, tomorrow may become mainstream and may not be considered AI. So where do I use AI? Google search, everybody uses it. Photos, Facebook, when Facebook tags your face and tells you, hey, is that you? Or tells you, we have identified you, that is machine learning at work. Self-driving cars, almost everybody has heard of it. Netflix recommendation, Amazon recommendations, AI or machine learning. So Alexa, Siri, hello Google, all of us, maps, all of us use these every day. So AI and machine learning is part and parcel of our everyday life. Good. If AI is that big a thing, and I'm predicting, not I, just everybody is predicting, in next 5 to 10 years, almost every little thing that you do would have an AI component in it, means you need to have a lot of people who are AI experts. So what kind of knowledge is required to become an AI expert or machine learning programmer or machine learning expert? One, you need statistics and mathematics knowledge. Of course, you can do even without statistics and mathematics knowledge, but then you wouldn't really go far. If you want to really understand the algorithms and the metrics and why they are working and how they are working, and in a given situation, which would be a better algorithm to choose and so on, statistics and mathematics knowledge would be very, very helpful. Of course, you need to have programming knowledge. For example, a lot of different algorithms you need to understand. You need to understand what are the libraries that are available that implement these algorithms or the frameworks. And then you need to make use of those frameworks and libraries by writing a little bit of code in some language. So for example, Python, R. Java can also be used. A lot of people when they need power or speed in their AI models, use C++ as well, and so on. So you need all that, which is very good, if from a machine learning engineer developer perspective. What about testing? What skills do I need as a tester? That's a question. Hopefully by the end of the session, you would have that answer, but I'll give you a short answer right now. You need a bit of statistics and mathematics knowledge. You need a bit of programming knowledge. So you can start picking up Python, for example, which is a general purpose scripting language, very useful for automation of any time. You want to do Selenium automation, you can do it. You want to do API automation, you can do it using Python. You want to do machine learning, you can do it using Python, and so on. And a lot of testing knowledge of certain type, which we will see soon. And of course, you need to understand machine learning before you start testing it. So let's go through the AI and ML fundamentals. So we have already discussed what is machine learning. I've said, you look at the past data and find patterns, and then use those patterns to predict the future. For example, look at past data from stock market, let's say last 1 year, last 5 years, last 10 years, whatever, and all the market conditions and environment conditions. You can feed in as much data as you want. For example, weather conditions, political events that happened, production, rainfall. You can feed in all that data, and you can ask the machine to make sense of all of it, so that tomorrow, what is the price of a particular stock going to be, the machine can predict. So essentially, machine learns the patterns from the past data and tries to predict the future. That is essentially machine learning. I'll give you an example of machine learning. So let's all become machines and let's learn from this example. What you see on your screen, kind of table, has two variables, x and y. X is input, y is output. I feed my machine, and I'm feeding you with this data. I'm feeding input 1, and I'm telling the machine output is 1. Please find a relation between x and y. The machine says, okay, give me more data. So I give 2, and I give the output as 4. Then I give 5, and I give 25. And at this point of time, machine says, okay, got it, don't worry. And then you give 8. What do you think is the output going to be? What's the relationship between input and output that the machine might have found? Go ahead, please. 64. Thank you so much. All right. Now, what I'm going to show you, first of all, what has machine learning done? Found patterns, relationship between input and output. What I'm going to show you now is this similar kind of table, and this table will unroll very slowly. I would request you to look at the x and y, the input and the output, and quickly form a relationship between them, find the pattern between input and output. Okay, so do that, please. So 3 and 12, 6 and 24, 9 and 36. Can somebody give me an answer? What is the relationship? Yes, please. Into 4. Actually, divide by 4. So 3. So 12 divided by 4 is 3. 24 divided by 3 is 6. 36 divided by 3 is, 4. 36 divided by 4 is 9. 52 divided by 4 is it 7? Clearly, the relationship and the pattern has broken down. Now take a look at it again and tell me the input-output relationship. Anybody? Nine, perfectly fine. How? Guru Hema. So, sum of 2 digits, right? Sum of the digits of x is equal to y. All right. So please don't use the Q&A. Please use the chat to give your answers. Thank you so much. Very helpful. All right, guys. So what did we see? We saw if you have more data, it gives you better experience, better prediction. So that is the most important part of machine learning. You need to have sufficient data for the machine to learn from it. Otherwise, patterns cannot be figured out. Good. So we have learned a lesson related to machine learning. Now, what all different types of machine learning? So you see a bunch of names here: supervised or directed machine learning, unsupervised or undirected, semi-supervised, reinforcement, and so on and so forth. Rather than going into these names, let us try to do some interesting stuff. Okay, I'm going to stop sharing my screen and share some other part of the screen. What are we going to do? Google has created a website. All of you can go to this website later. Teachable Machine. So if you just search for Teachable Machine, it will take you to teachablemachinewithgoogle.com. Well, it's very intuitive, very memory friendly name, teachablemachinewithgoogle.com. So we'll go there. Let's see. Can you guys see my screen? Teachablemachinewithgoogle.com. I hope you can. Yes. So we'll get started. So what does this website do? It has got some magic. So we are going to do some magic. We are going to start a new project. We are going to do machine learning. So the magic that I want to do right now is be able to identify cats and dogs from an image. Why would I want to identify cats and dogs? Well, maybe I've created a, think of Disney World. Cats and dogs roam around, and I have a store where a cat can come in or a dog can come in, and there's a robot which dispenses food based on whether it's cat or dog. So naturally, the robotic vision requires a distinction between cats and dogs. And so what we are going to do here today, which is an image project, we are going to use that. Okay, so this is going to be used. So you guys are going to do that. So next time you are going to figure in a Disney movie. So what is it that we want to identify? We'll call them as classes. Who cannot see the screen? Because people said you could see the screen, and hence I went ahead. Anyway, let me try to go back. Okay, now you can see it. Hopefully. Perfect. So teachablemachinewithgoogle.com, this is the basic website. Okay, and you come here, it can give you a lot more information, but we are going to get started with our own project. And in this own project, we are going to do an image project. So we are good. Now, what we are going to do is look at two classes. What class? Dog and cat. I don't care about rest of the world. I'm only interested in dogs and cats because it is said that the world is divided into two, cat people and dog people. Okay, so first thing, let's name our classes properly rather than class 1 and class 2. So this one I'm going to name as cat. Of course, it doesn't mean because I've written cat first that I'm a cat person. I'm a dog person. Second one, dog. Good. But how are we going to teach the machine that these are cats and these are dogs? So we'll feed it images of cats and images of dogs. So of course, we need to have those images. Fortunately, I already have cats and dog images with me. So I am going to select cat and dog images. And my website says you can use a webcam to add images. But unfortunately, if I open my webcam, I don't think it's going to recognize me as a cat. So I would upload cat images. You can import them from Google Drive, or you can drag and drop. So I'm going to drag and drop. Here, I have dropped 14 files. Perfect. Now what's remaining? Dog images. So let's put dog images as well there. And I am putting dog images as well. Perfect. Now what do we need to do? So you see here training, train the model. And there are some advanced things like epochs, batch size, learning rate. Let's not worry about it. Okay. We are just going to say there's magic. Google has created magic. And behind this box is magic. We say train model. And Google is trying to do its magic. Let's see. So preparing training data. So you understand, we got the data. We labeled the data. We classified the data as cat data, dog data, and we supplied it. And then Google did some magic of preparing the data. And now it is training. And of the 50 epochs that were there, it ran through all of them. And now it says model has been trained. Now that's wonderful. That's quick as well. But let's see what has been trained. It says, sorry, webcam couldn't be opened, but I'm not interested in webcam. I'm neither dog nor cat. So I will give my input. So we need to test it now, correct? So what do we want to do? Now we drop some random images here of cats and dogs and see if it identifies cats and dogs. In a typical traditional program, what I would do is, just a moment before my system runs out of charge, let me plug in the charger. Typically, if I give a traditional system an image of a dog or a cat, I would expect the system to say, this is a cat, this is a dog. I don't expect the system to do anything other than that. But let's see what the system does here. So I'm going to feed in some cat images and some dog images. So let us try to feed in first cat image. Okay, here I have dropped it. It says 100% cat, 0% dog. Very good. I'm very happy. How about this one? 100%. How about this one? Very good. So it is able to recognize all cats. So that's one part of my test done, correct? Now, how about dogs? So I say, okay, let us take a look at the dog. 100% dog. 100% dog, right? Oops. 47% cat, 53% dog, still better, correct? This is a cat for sure, right? Okay. Now, what is it that we have done so far? Let me lay down all the steps. First thing, we identified the problem statement. We said we want to identify cats and dogs. Because we want to identify cats and dogs, we are saying I want to classify this image either as a cat image or a dog image. For that, I downloaded the data from somewhere, or I obtained the data from somewhere. So data procurement or data collection or whatever. After that, I labeled the data, meaning I classified the data. These are cat images because I want the system to learn from these images. Hey, come on. Hello. Can somebody please make me the host again? I don't know what happened. Thank you so much. Let me share the screen once again. Okay, good that we are back. So what did we do? Data preparation. Once the data was prepared, we trained the model. And the model got trained. And by the way, we don't know what algorithm was used, but since it uses epochs and batch size, we clearly know this is neural network. Now, what kind of neural network? Let's not worry too much about it. Typically, CNNs are used. But once it got trained, the model got trained, it outputted a model. And you can see then that, it generated something, which let's call it as a model or a program. And now when I give it cat or dog images, it gives me the answer. I can export the model, as you can see here on this. Now, what does export mean? I will explain that also in a short while from now. And you also would have noticed that the results are coming in percentages. It's not 100% cat or 100% dog all the time. And even those 100%, even that is actually a probability. So the answer in this case in machine learning is probabilistic. So what we did right now, all this, we have gone through entire machine learning life cycle once. Right from collection of data to predictions, we've done everything. And we have understood that machine learning gives results which are non-deterministic, which are probabilistic. Okay, so let us take a look at what exactly are we talking about. So what we did was actually called as supervised learning. Why supervised or directed? Because when we taught the machine, we told the machine this is the output. So essentially we gave the machine inputs, and also for all these inputs, what are the corresponding outputs? So these are known as ground truth also. So we provided data with input and output both, and the model got trained, and output was a trained model. This is known as training phase. We can also call it as offline phase. Okay. So in the training phase, model gets trained. Then we went to give new input to the trained model, and it gave you the best guess, and this is prediction phase. And because we used labeled data, this is known as supervised. Because we were classifying the images into one of the two categories, dogs and cats, that is why this is called as classification. So we have learned about supervised classification. I told you about stock market. That is also a supervised learning. But in that case, you are not outputting into a class. You are saying what is the stock price going to be. So your output is a continuous quantity. That is known as regression. All testers, please understand, regression is different from the regression we know as testers. So this is known as supervised regression. So there are two types of supervised learning: supervised regression and supervised classification. I hope you're clear about it. Then we move on to next one. For example, and you know that collecting all these images might actually be very expensive, correct? So sometimes you do not have these outputs available. You don't have time to create those outputs and so on. So what do? So you say, is it possible for me to use the input data without looking at the output? And what kind of problems can I solve? Certainly, there are certain types of problems that can be solved. For example, let's say I have 50,000 images. Some are cat images, some are dog images, some are human images, some are vehicle images, and I want to sort them out all separately. So I don't know how many different types of things are there. There could be buses, there could be cars, but I somehow want this system to automatically make sense of it and put similar images together. So I give all the data to my algorithm and say find similar images. And what do I expect? As many different object types are there in those images, system will classify. I'm using the word classify loosely, will put all relevant images together. So all cat images together, all dog images together, all car images together, and so on and so forth. Now this, what I'm doing is clustering. I am trying to cluster similar things together. So this is known as clustering, where I beforehand don't have the outputs, and there could be 4 clusters, 5 clusters, 10 clusters that I have to decide. And that is where this whole machine learning engineer works, where tries to find out how many clusters should I choose and so on. And after clustering, if I go into each cluster and see what is relevant data, for images, of course, it is relatively easy to figure out if clustering is proper or not. But this is an example of clustering. Now, then there is something called as association. When you go to supermarket and you want to buy bread, chances are you'll also want to buy butter or milk and something like that. So which means that when you're buying bread, if butter is nearby and milk is nearby, or if you create some schemes, then you are more likely to prompt people to buy those things and so on, because they're already inclined towards it and so on. So when you do this kind of an analysis, it is called as market basket analysis. You don't need any preferred output. You don't know what is the output that is already there. You want the system to find out these kind of patterns. So all these are known as unsupervised learning. So when you put things together, this is known as clustering. So unsupervised clustering, unsupervised association. Unsupervised association, for example, Amazon, when it tells you, Amazon, Flipkart, whatever, when it tells you, you may want to look at this, or Netflix recommends something. So recommendation engines, etc., are example of this. Okay. And then there is something called as supervised and unsupervised. Beyond that, you say, I don't have data, because supervised and unsupervised both need data. Supervised, you said, I have output also. Then you went back one step and said, no, I don't have output. So you came to unsupervised. Now I say, I don't even have data. What to do? So the system in this case works without data. So what do? In this case, you have a software called as agent, and you have an environment within which the agent is supposed to work. Think of a robot. Think of a lawnmower, automated lawnmower, for example. And the robot interacts with its environment. If it does something wrong, when you are training it, it does something wrong, you penalize the agent heavily. And when it does something right, you reward it. And the robot keeps doing random things, and in the process learns what are the right things to do, what are the wrong things to do, and so on. So when you don't have data and you have interaction of the software with the environment, then reinforcement learning is the best thing to do. And there's a new stream in reinforcement learning called deep reinforcement learning, which is, a lot of research is going on there. Now, reinforcement learning is used for playing games in driverless cars and robotic visions and so on. So let me show you something interesting for reinforcement learning. Can you see my browser? Please let me know. What do you see here? So this is an example of a game, Breakout, and reinforcement learning is happening. So this is the initial performance. The game keeps doing random moves. For example, this pedal here keeps moving randomly, and whenever the ball drops and it is penalized. Whenever it hits a brick and breaks it, it is given a reward. And this is after 15 minutes of training. You can see it is not moving randomly. It is doing some good job, but you keep training it. And after 30 minutes of training, you can see on the right hand side screen that it plays the game really well. You didn't teach any rule. You didn't teach anything. You just taught, applied the penalty or reward, and that's it. This is an example of reinforcement learning. Okay. So I hope you can see my presentation now. So what is it that we have looked at? Structured learning, classification and regression, then supervised learning, then unsupervised learning, which was clustering and association, and then we have looked at reinforcement learning. So we are good with that, I hope. But when we talk of all this, we also need to understand the kind of data that is handled, structured and unstructured. When your data is in tabular format, either in an Excel or a table or in a database, this is all structured data. Structured data has a structure, it has a meaning, it has certain syntax and certain rules and so on. Structured data is usually easy to handle. However, unstructured data, for example, the emails that you write, the blog posts that you write, the tweets that you do, the Facebook posts that you do, images, what you tell Alexa to do, audio, right? So videos, all of these are unstructured data. Handling unstructured data generally is very difficult. And before the advent of neural nets, people would take unstructured data, would extract some meaningful information out of it, convert it into structured manner, feed it to the machine, and then machine will learn from it. Machine learning used to be a tough task. But with neural networks, all you do is, for example, feed the image, tell the neural net what this is all about, and neural net learns by itself and so on. So structured data, unstructured data. Now let's move on to what exactly is machine learning. All this is good from point of view of UI, but what does machine learning code really look like, and what do you do in machine learning? Let's take a look at it. Next time when you see machine learning engineers, you can tell them, you guys don't really write any code, but you get paid so much. So let's see what kind of code they write. First thing that we want to do is train the model. After that, we may want to, once the model is trained, let's say on my local machine, you want to save the model and then move the model from my machine to, let's say, deploy it on a cloud. And then you want to connect to that model, give it input, and you want some output. So these lines of code, they do all this. Actually, if you look at it, not more than 1 or 2 lines of code. So you declare some variable. We are training the model, the first block, the first function, train the model, and we choose the algorithm for which we are using. And the algorithm we have chosen is logistic regression. So let's not worry too much about what algorithm and so on. And after that, we are just using one line saying for the algorithm that we have chosen and for the blank model that we have, use fit. So model.fit. Fit means train the model. I supplied the input, X is my input, Y is the corresponding output. So my model takes the inputs, their corresponding outputs, and gets trained. Once it gets trained, after that, all I need to do is do the prediction, and for that, model.predict. And I supply the input, I get the output. That's it. So it's very interesting that just one line of code, one line to choose the algorithm, one line to train the model, one line to predict. And to save, all you have to use is pickle.dump and the model gets saved. And then I want to load it. So all I do is open that file and load it. That's it. So you see, machine learning code is, the code itself is not really too much. Where these people get, do things, understand the data, understand what algorithms would work, what kind of a problem it is, what kind of solution is required. And once you get the data, you do whatever needs to be done with the data, you basically create a model and you test it. And you find that the model is not good enough. So that is where the real skill is. Now you ask yourself, how can I improve the model? Should I use different algorithm? Should I use more data, less data, different type of data? Should I play with the algorithm parameters known as hyperparameters, for example? So should I do those? And at what point of time do I get a model which is satisfactory for my business needs? So that is basically what machine learning engineers do. So with that, I hope you understand at an overview what machine learning is, what models are, how they are created, what are different types of machine learning, and how does the code really look like. Time to move to testing of AI. So the question is, am I going to use machine learning to test my applications. Of course, I can use machine learning to test my applications. So if my application is AI itself, can I use AI to test AI? That's a question. Can I use AI to help my testing, and in what ways? Can I use AI in development? In what ways? Can I use AI in automation? How? So those are kind of things we'll briefly take a look at. First, how to test AI. Now, the interesting thing about how to test AI is that while a lot of people are trying to use AI in testing and in automation, very few people are thinking about how to test AI at a commercial scale. Some bit of research is happening. So you see some papers published and so on. But how these things have been used in real world, for example, Uber or Facebook, some of them may actually open source some of their AI testing tools and so on. But rest of the world, either it doesn't know how to test AI, or whatever is available, we use only that, and a lot of more research is required, or we just test AI as black box testing and we are happy with that. So let us take a look at how AI can be tested. Now, we looked at two things: training phase and prediction phase. Prediction phase is also known as inference. So essentially, when you put your model on the production server and you want it to make inferences, then it is known as inferencing. So you can test it at the stage of offline, which is the training stage. So the moment model gets trained, you ask yourself, is the training good enough? And once you say training is good enough, then you integrate your model in rest of the non-AI stuff. Just to give you an example, when you use Google Maps and it gives you path between point A to point B using machine learning, for example, then the portion of the algorithm which gives you the path is the AI part, but the UI that gets rendered, the directions that you see, and when you click somewhere, something happens, all that is non-AI. So pure AI model doesn't exist in the world. Mostly it is with a lot of non-AI around it. So you have to understand there are traditional testing opportunities in an AI program, and to test the AI model, there are other opportunities. So the moment I say model is integrated with the non-AI component, so basically integration testing, system integration testing, everything that we know as a tester, they are all relevant. So first, let's take a look at AI lifecycle. What I showed you was a life cycle in one way, but I'm going to show you another way to look at the life cycle. Okay. So what is this life cycle all about? Data acquisition. Now, please go back to the scene of collecting all the images and so on. We acquired the data, in this case from Google, but Google may not have all the answers. There may be cost implications. You may need to create your own data. Data acquisition is not an easy thing. And without data, there's no machine learning. So data acquisition. Typically, data acquisition and the next step, data preparation, forms one of the most expensive part in terms of time, etc., for AI or machine learning problems. So then you take the data, you prepare the data. If it is image, for example, setting the size, dealing with the brightness, contrast, or the file format, and so on. If it is text, then you want to do 1,000 other things with text, like remove full stop, comma, etc., remove the articles, remove various forms. So there are a lot of words that are used for this. I'm not going there right now, but you can do all of this pre-processing on the word. Similarly, for audio also, you have pre-processing. Once you have your data prepared, then you say, okay, what is going to work for me? Which framework am I going to use? Which algorithm am I going to use? And then basically you feed in the data, and the model comes out. You evaluate the model. You try to understand if the model is looking at the data correctly, and is it accurate enough? If not, you go through the whole process again. And then once it is done, then you deploy. So don't look at the development. It's actually deployment, step 5. Once the model is prepared, you deploy. And then, you operate the model. And at some point of time, you find the model has started to go bad because it's no longer making good predictions because things have changed, circumstances have changed. For example, related to growth of the industry, the models would have predicted something. And once the coronavirus became a reality, and once the lockdown became a reality, all those models would fail. So now you would need to train the models again. So that is the whole part of optimization. And then you go through the whole cycle once again. So you can help and support step one, step two, definitely step 3 and 4 if you have knowledge, and testing definitely at 5 and 6. We definitely do that. So let's take a look at how do you evaluate a model. I'm not going to go too deep into it. I'm just telling you, for each type of learning, supervised classification or regression, unsupervised clustering or association, there are a lot of different metrics that are used. So essentially, the moment I create a metric, I try to measure the performance of my model. And the moment I create the model, I choose appropriate metric and find out if that metric has right data, which tells me that the model is okay. For example, cats and dogs. I'll take that example. If it predicts all dogs correctly, all cats correctly, I say true positive and true negative, they're all good 100%. But if some cats are identified as dogs or dogs are identified as cat, we have false positives and false negatives and so on. So how many false positives, how many false negatives do I have? And ratios of many of those will give you accuracy, precision, recall, and so on. This is called as confusion metric. So this is an example of type of metric. And based on that, based on your need, based on your business problem you're trying to solve, one or more of these parameters may fall in the right or wrong. And if they are not correct, meaning they are not in the range that you want, then you need to train your model again. It may so happen that despite your best effort, despite your best data, model may not achieve the kind of accuracy you want it to achieve. Then you may have to discard the whole machine learning. This is one thing that is quite possible. Similarly, there are other metrics, but we are not going to take you through them. So having learned, that there are a lot of metrics, why did I show that to you? There was a specific reason. Because when you go and talk to the CTOs and the CXOs, when you go and talk to machine learning engineers, those who do not have a lot of industry experience and so on, you would actually find many of them telling you testing is not needed. Separate testing is not needed in machine learning. Why? Oh, we have testing built into it. How? You'd see all these metrics that we're talking about. We have this much data, we have algorithms, we split the data into training data and testing data. So we use this much data for training and then we go for testing. The model automatically tests it and gives its information about the metric, and that's good enough. So my friends, that is not good enough, because if that were good enough, then AI would never fail to do what it is supposed to be doing. It is like, somebody saying, oh, my developer writes unit tests, so that should be good enough. Well, unit tests are part of development process. They are built into it. But that doesn't mean everybody writes unit tests. That doesn't mean everybody writes unit tests in the same way or detailed enough. And it also doesn't mean that if you have written good enough unit tests, there'll be no system test bugs. So you need testing at all stages. However, people are not yet there. So let us take a look at how AI testing is different from traditional testing. The first problem you have is Oracle availability. What is Oracle availability? What is an Oracle? It's a company, it's a database. Well, actually, Oracle is also, if you remember this film, The Matrix, especially part 1, there was an Oracle. What did the Oracle do? Predict future. So what future do you want to get predicted when you're testing? When you're running a test case, the future you predict is the expected result. So any source of expected result, anything that tells you the expected result is an Oracle. So for example, your requirements, maybe your design document also, maybe help files, maybe a similar program, maybe an old version of the program, and so on. But in case of AI, you really don't have an Oracle most of the times. So if you don't have an Oracle which can tell you what is the expected result, because we saw 100%, 50% dog, 50% cat, 52% dog, 48% cat, is that good enough? So those are the kind of things that we need to look at. So Oracle availability is a serious problem. Okay. Then I'm sorry, we saw that the results are probabilistic, they are non-deterministic. Is that good enough? That's a question. Why did it say 48% cat and 52% dog? Why not 100% dog? Can the model explain that to me? That was not available. So essentially lack of explainability of why the model did what it did. And then issues related to coverage. How much coverage have I got in terms of data? I will come back to the coverage part. And then, data requirements. Without huge amount of data for both development and testing, machine learning cannot happen. For testing, you need skills related to machine learning. Many people do not have those skills. Don't worry about the last thing. We'll discuss it if time permits later. So at this point of time, it should be clear to you that you can do machine learning testing if you have domain knowledge from a domain perspective, and especially in the online phase. You'll not be specifically testing machine learning models, but you would be testing the overall system. So you can do that. So this is like regular testing that can continue to be done. Okay. If you want to be machine learning testing expert, then you will see soon that there are other things that you need to learn. So let's take a look at it. So what's the state of practice today? Very much like, my early days of software testing. I'm probably one of the first few testers of the country, career testers, I mean. I joined way back in 94 as a developer, early 95 actually. I was a developer for some time, and then I was moved into testing as career testing. No company in the country, Infosys had a few thousand people, I believe, at that point of time as employees. Vishal has raised a hand here. Vishal, tell me, do you have a question? So while the question comes, just give me a second. Let me see if I can have the chat window come up. Okay, no problem, Vishal. Now, when I was one of the first few testers of the country, there was no company which had a testing department. In fact, testing departments started to come in only after 2000 when the Y2K happened and so on. Of course, some testers came in before that, but 25 years almost I've been in testing. I saw in the beginning, developers did all their testing. They didn't understand the system perspective. They didn't understand the user perspective. Only few would do. And nobody had time to test it from that point of view. So systems would get rolled out. Since there were less number of users, many problems would not get discovered or get communicated, or they would get discovered in the field and fixed and so on. So all those things used to happen. We are in a similar state for AI testing today, where we don't have set processes. We don't know where testers to get involved, what skills do they need, what roles would they play, what kind of tools do they need, and so on. So I have one of my companies, Test AING or TAI, is in this area. We are the world's first AI focused testing services company. We are also building AI testing product, which will help test AI applications. So it's not really an automation product. We are not in that space at all. We are thinking of how can we test models, how can we test AI applications, and we are doing a lot of research there. We have tie-ups with some colleges, research students, and so on. And I just hope something good comes out of it. Let's see. So where is the research in AI testing going on? In something called as metamorphic testing, and I'll explain that in a short while from now. Research in I talked about deep learning and deep neural networks. So essentially some sort of white box coverage of neurons. So that is basically neuron coverage or neural coverage. Then there are issues related to bias and so on. So research is going on that to detect bias. Research in generation of data, because all the time it is very difficult to essentially capture data, create data. So you need synthetic data. and you need some sort of automated model selection and so on. So all those things are happening. Let me show you something interesting. It wasn't really part of what I was going to show. So guys, what you're going to do is, you're going to tell me which of the face on your right or left, which one is real. You will tell me that, and I will click that, and then we'll see whether that face is real or is it a synthetic face. Yeah, tell me quickly. Which face is real, left or right? You say the right face is real. Let's select right. You're correct. Let's play it again. Which face is real, left or right? Quickly. So I'm getting both left and right. I'll choose left. So those who said right, this is a computer generated face. Interesting. I'll do it once more, last time. Which one? Left or right? Again, we've got a lot of lefts, some rights. Good. So, of course, we could be right or wrong depending on, so, I'm not telling you the algorithm, what it is doing and so on, or how can you detect. But the interesting part in this, which one, right or left? Okay, a lot of rights. Let me choose right. You are incorrect. The image on the left is the real one. All right, wonderful. So we have played that game. What was that? So you have something called as adversarial networks, which are used to generate images. So first you generate a synthetic image, you feed it to using a neural net, let's say, and you feed it to another model, to which you say, you know what, this is a fake image. And you feed it some real images, and this is a real image. And then, you pass on this information back to the first network saying this particular image was detected as fake. So it tries to improve and then outputs another image. You feed it to the second or the next model. If it is able to detect that it is a fake image, you send that information back. So in this way, you are using these two networks in adversarial mode, and one improves the other one. And at some point of time, you reach where the model itself, the adversarial model, for example, is not able to distinguish between real and fake images. We have come a long way. The images are almost realistic, but hopefully within another year or two, people would be able to create images which will be totally indistinguishable from real images. So that's a very interesting thing that is happening. Now you can imagine all the video surveillance and all becomes totally useless. Okay, so that is data generation that we are talking about. Okay, now we created a model. We looked at some of the metrics. Is that the only way to look at model, or there are some other ways to look at the model as well? So from the metrics point of view, accuracy and all related things can be put into it. But is my model robust? When I give it wrong inputs, is it able to handle it properly? If negative events happen in the system, is it able to handle them properly without crashing? How quick it is? Does it continuously learn and evolve, or is it that it doesn't learn, it's a static model? If I have a lot of load, is the model scalable? Can I test the model testability? So these are some of the parameters on which learning system need to be evaluated by testers. And where do you evaluate them? Most people today don't evaluate them, or evaluate it as an afterthought, sometimes at training phase, but mostly at prediction phase, which is not a good thing. You need to do it at all levels. So I'm not going to take you through what is meant by accuracy, robustness, speed, complexity, continuous learning, scalability, testability. These are standard terms, but I'm saying you need to apply these to models as well. But there are some new quality characteristics that need to be brought into picture. For example, if your model is fit into a robot, for example, and the robot goes around doing things. Is it depicting intelligent behavior, or the model itself depicting intelligent behavior? Meaning, is it able to learn? Is it able to improvise? So that is continuous learning. Does it tell you why it made a choice that it made? Does it make for natural interaction? So if you remember, I think Sundar Pichai made gave a demo where an AI made a phone call to book a appointment with a hairdresser. So there was voice, and it was speaking like a human being with pauses and and those kind of sounds. And let me check. And apparently, the person on the other end didn't realize that she is talking to an AI. So natural interaction. However, that brought in the question of ethics and morality. The current understanding is that a machine, if you are using a machine to interact with somebody, because the person can't see you because it's a phone call, the agent should identify itself as a non-human agent. Or for example, when you go to a chatbot, you want to know whether you are interacting with a chatbot or you are interacting with a human being. So disclosure is important. In this case, there was no disclosure. So did the demo fail on, it succeeded on natural interaction, but did it fail on ethics? So that's a question. So suddenly in testing, ethics, morality, privacy, human friendliness, all of these things become really important. And then there are, rest of the stuff, things like personality, because you saw that gargoyle, right? So things like humor, empathy, mood, all these things become important. And humor is a double-edged sword. Somebody's humor is somebody's insult. For example, that person saying, "Sir, are you stealing a desk?" could be taken as an insult. So it's rest in confused face could be taken as an insult. So, when your systems reach that stage where they start to have a personality, or where you could choose a personality, you'll have to test it from that perspective as well. So in fact, testers, developers, what you need are philosophers who can actually look at all these ethical aspects and so on, and figure out if your AI system is working within the ethical and moral compass. Now that's something interesting I'd like to talk about. There's nothing called as universal ethics. Ethics are dependent on geography, on space and time both. What was ethical yesterday may not be ethical today. What is ethical today may not be ethical or moral or the right way to do things tomorrow. So to judge past with the standards of today is generally a bad thing, because everybody's, as they say, product of their time and so on. Nothing wrong there. But what I'm trying to say here is that China has a different human behavior system where humans interact, hierarchy of human beings, ethical and moral compass and values. India has a different one. Europe has a different one. Today, what we see in most of the literature is something that comes from the European sense of ethics and morality, or the Western sense of ethics and morality, which may not be compatible with, for example, the Chinese culture or Indian culture or African culture and so on. So testers at some point of time need to start looking into these aspects as well. Now, coming back to the hard aspects, let's see how much time I have. I think I have consumed something like 90 minutes almost, 80 minutes actually. So I need to finish it in next 15-20 minutes so that we can have questions. So let's take a look at metamorphic testing. What is metamorphic testing? If I ask you to multiply a 9-digit number with a 9-digit number, can you tell me what is the output going to be? 3748615432 into 123784956. What's the output? Well, if you don't know whether the output that has come is correct or not, and you have no means of ascertaining that because of Oracle problem, one thing you can be sure of, that if I increase any one of these numbers, the output should increase. You can also say maybe the output should increase by, if I increase one number by 1. So for example, if I multiplied 5 and 9, if I increase 5 by 1, meaning I make it 6 into 9, I know If 9 gets added to the output, then that would be the correct result. So if that is happening, that means system might be behaving correctly. So I am finding a relationship between input and output. And that is a simple relationship. This is known as metamorphic relationship. I try to identify as many metamorphic relationships as I can. And then I change the inputs and see that the metamorphic relations hold. And if they don't hold, then I say the system may have a bug. Or the system might be having a bug. So essentially, you are testing for metamorphic relations. So that is metamorphic testing. I think late 90s or early 2000s, that is when metamorphic testing came out for the first time. It was to be used when you don't have an Oracle or you have Oracle problem, but it wasn't picked up by anybody. But with machine learning and the problem of Oracle, a lot of people are talking about research in metamorphic testing. Then there's a question of ethics and AI. While there are a lot of things that I have written here in terms of ethics and so on, but I will just talk about one or two things. Ethics is an emerging concern, an emerging discipline for AI. If I have a driverless car, I'm sitting in that car, and I'm on a T point from left at a very high speed, no brakes, a bus is coming, which has a lot of elderly people. From right hand side, a car is coming, which has a lot of children, and my car is going to strike at least one of them. Probably only one of them, but one of them. There's no other alternative. What should the car do? Should it go and strike with the bus and kill maximum number of elderly but save all the children? Or kill the children and save a large number of elderlies that are there? Now, what will a human being do? Unfortunately, nobody knows what a particular human being will do, and could go either way, and we are okay with that. But with the machine, we want determinism. Now, what kind of rules should be applied here? You can't leave it just like that, right? It's a scenario, it needs to be tested, you need to have an expected output. So that's the kind of problem I'm talking about. Well, there's another way to look at it. You might say, hey, I bought this car, it's supposed to protect me. So rather than thinking of who it is killing, it should think of who should it strike so that I can be saved. That's also a perfectly valid way to look at it. But my life versus life of, let's say, 5 children versus life of 20 elderly people. So you understand where I am going with that. Then there's a question of bias. Bias is unfairness. The system learns from the data. As a kid, I remember I used to go with one person who's our cook. He would take me to the market, and I come from a place called Bikaner, where swearing is a very common thing. It has become less common now, but nobody really minded it. I believe it's so similar case in a lot of different small cities in the country, including Banaras, where there was a film called Kashi Ki Assi, and a lot of swear words are used. It's part of normal everyday language. So this guy would teach me some swear words and say, if somebody came in front of my bicycle, he would say this, and I would say that, and then he would tell me, don't go and say this at your home. Okay, and then one day I said those words at home. Of course, I had thrashing of of my life, and the guy got a verbal thrashing. But did I do anything wrong? I learned what I was taught, right? So is the case with model. If you give it garbage data, it'll learn garbage. So if you give it data for salary data for all the women in the world, which has a clear bias that they get 10 to 20% less salary for the same job, same qualification and everything else, and you ask it to fix up the salary of the people, it learns from the data women get less salary. So when it makes its salary package, it will give less to the women. Now that is an example of bias, right? So, take a look at the last bullet point. So somebody ran this experiment. There are a lot of pre-trained models or facial recognition training data sets that are available, and software have to be, software is available which tells you this. What you found out is, what these people found out is that 75% male figures were used to train these models, and only 25% were female figures. So you're already biased towards male. 80% of the figures that were there were white. So you are biased towards white. So if you want to go to the other extreme, what would you want to be? You would look at a non-male, non-white. So a dark-skinned women, for example. And they actually tested various models. They found white men were recognized with 99% accuracy, and dark-skinned women between 66 to 80%. So that's not a nice thing. That means you need to look at your data, figure out the biases in the data, and that's where again testers can be very helpful. And again, people are working on tools to detect biases and so on, and have unbiased data. And then you still find bias in your model. You figure out why and train it again and so on. Okay. So that is what we are talking about in terms of bias. Now, where are testers going to be involved? What type of involvement? Do I need programming skills and so on? I hope you understand now. If you know programming, if you know a little bit of how to create models, they go, a lot further. But you need to understand metamorphic testing, maybe things like neural coverage. You need to understand bias. You need to understand explainability and so on. But first, a quick example. What you see on your right-hand side are two images. Wolf and first wolf was recognized very clearly by a model that I trained, and the second model, which was working all right, it recognized wolves and huskies, which look almost same, very easily, but then it didn't recognize one husky picture. It recognized it as wolf, and so somebody started, or it recognized a wolf as a husky. So people started wondering why this is happening, and they, after a lot of investigation, what did they figure out? Any guesses? All the training data they had for wolf had snow as the background. All the huskies had forest as the background, or greenery as the background. So it didn't really recognize either a dog or a wolf. What did it recognize? White and green, and it found out white equal to wolf, green equal to husky. Please understand, human beings, when we look at images, we don't look at pixels. We look at objects, but somebody has trained us to look at the objects, right? So first time your parents tell you glass, and so you get this, you understand it's glass. However, what a camera does is capture pixels, and then somehow, in a two-dimensional plane, all the pixels are there. Somehow you have to recognize that all these pixels, these set of pixels actually are a glass, right? That's where all the vision algorithms come in. A lot of research happens in that area and so on. So this is another example. So what is it? We have done our first ML learning through mistakes. So I need some explainability. Why is the image saying it's a wolf or it's a dog? There are many methods available. Lime is one. It is independent of model type. And there's another one called GradCam, which is useful only for CNNs, convolutional neural networks. And it tells you which part of the image made it recognize it as a dog or a cat. So take a look on the top row. On this image, we asked, please tell us what made you recognize it as cat, and it shows you the darkest red. This was the portion that made me recognize it as a cat. The darkest portion in dog made me, this is the portion, meaning the nose and the mouth area, which made me recognize it as a dog. I'm happy. It's quite possible that it could have looked at the background, the door, for example, that you see here, and said, this is cat. Then I would clearly know it is wrong. Okay. Now, just one more example, and that tells you how difficult it is to do AI testing. This lady died, an autonomous vehicle ran over her. So the lady was somewhere here. She jumped out on the road from an intersection. It was a dark road. The car was going. The car used lidar, images, radar, everything, and it recognized that. And it recognized that what you had initially was a vehicle. Then it recognized it as a bicycle. Then it recognized the woman as well. And by the time it recognized all of that and then thought that I have to apply brake, the car was too close to the woman and it ran it over. There was no emergency braking. Think about it. Why did it take time to recognize the cycle? So you may say, was some data given to the car or to the model to, which had bicycle on the road, which had a woman with a bicycle on the road, which had a woman wearing a flowery dress with bicycle on the road, with a lot of flowers or plants loaded on the bicycle, with some pattern on the bicycle, with certain, play of light and darkness, and just, coming out suddenly, not 1 kilometer away, but just, maybe 50 meters away. So what are we talking about? There's so many scenarios. And how would you actually take care of these scenarios? You need to capture these videos, and then you need to feed these videos to your model for it to recognize, to train it. And if you have not captured this kind of a video, this kind of a training hasn't happened, then you will certainly have a lot of problem. So tens of thousands of hours of driving data is available publicly. It's much more data is available with people who are doing trials of driverless cars, but they can't cater to every single situation. So essentially, think about some of the test cases like this that we talked about. We didn't even talk about the woman's movement in this way, or erratically, or just stopped. Or maybe the woman throws away the cycle and goes in different direction. Now the car has two different moving objects to track and decide which one it wants to hit, and so on. So you understand what we're talking about? This is a problem of AI testing. Too many variables, too many combinations. So there is a technique I have developed using which you can generate huge number of test cases and combinations. You'll get a link pretty soon. Okay. How can AI be used for testing? Just search for Candy Crush genetic algorithms, AI or machine learning, and you will get a post which will tell you how beautifully Candy Crush people used genetic algorithms to automate some of their testing. For every level of Candy Crush, it took them hours and hours to test it to see whether it is all okay or not. So what are we talking about then? They took genetic algorithms, and the algorithm that produced the best results, they mixed them up and then continued working on it. And after a certain point of time, they had good algorithms, and that allowed them to test Candy Crush very, very quickly. So that is the use of AI in testing. You can use AI for user interface testing, functional testing, traditional automation, defect analysis, defect prediction, a lot of such things. You can use AI for test estimation and risk analysis. You can also use it for test data generation, and so on. So let's take a look at some of these things. However, if you want to understand how to write a large number of test cases, what you can do is take a look at my technique. If you search for my name and noun and verb or linguistic analysis method, you will hit upon YouTube with this technique. It's a 1.5 hour seminar I gave, and you might find that very useful. Let's get on to AI-based test automation quickly. And there are a lot of tools that exist which use AI in automation. One of such tools is 21 Labs, used for mobile automation. And they allow you to create this kind of maps when you connect your mobile and it captures your screens, it captures the objects, it captures what all screens you have encountered and connects them, that from this particular screen you can have this flow and that flow. And when you automate using it, if there is some sort of change in the object ID or some other thing, then it is able to heal that. So you don't need to do any maintenance. It automatically updates the test and so on. Similarly, there is a tool called ApplyTools. It uses image recognition and image comparison. So whatever has changed between two different versions, it identifies that to you. And then you can choose which change is okay and which change is not okay. So it uses AI-based image comparison. And then once you choose what is okay, what is not okay, it updates the baseline, and you can then continue to run the tests and so on. Testsigma also has a tool, and maybe at this point of time, I can ask KR if he's interested in talking a little bit about his tool. It's good that we have, person here who can actually talk about the tool. So would you want to, KR, if you are here? Okay, just give me one moment, folks. Need to look at the participants. Should I pass you control back to you, Lavanya or Shruti? Let me know, please. Or you can take the control back from me. Okay, go ahead, please.
Yeah, hi. So KR here. I think you may not be able to see me. So because of the low bandwidth, I may not be able to turn on my video. Thanks, Vipul, and it was really good. I mean, a good walkthrough and very good introduction, and it's not just an introduction, like very detailed walkthrough for like what is AI and how where it can be used, and the real. I mean, with all the realistic scenarios, it makes a lot of sense for all of us, including myself. And just to give a bit more about what is Testsigma and how it works. It's a test automation software that we all know by now. Also, like, I just want to quickly touch upon like where we use AI. So as Vipul was saying, like, so we may not be able to use the AI end to end from day one for most of the cases. Like, we just need to see the right areas and pick the right areas and also apply the right places. Only then we will be able to see better results. So there are four areas where we use AI in Testsigma. One is obviously the natural language processing that you are seeing in front of you, where you can write your scripts using simple English. And then we convert them into actionable scripts automatically, and need to write any script at all. The second part, second area where we use AI is the self-healing. So as Nikhil was mentioning in one of the other tools, let's say if there's any change in your application or anything in particular has changed, so we do auto-healing using artificial intelligence. So because we know that we have the data about your element. So what we do is, like, when you write your test case, we'll try to capture all the details that are needed to auto heal the test case, just in case if there's any failure. So with the data in hand, we'll be able to do a lot more, and like all these things. I mean, applying AI, or it's not AI. So as Vipul said, like, it's like ML, right? So use this AI ML logic to auto heal this test using the other attributes or the attributes of the entire page elements available with us. And the third area is like where we use AI. That's what is mentioned here. So we can identify the affected test cases and the potential failures upfront. Let's say there's a change in your one of the prerequisites, like login is a prerequisite most of the cases, right? If there is any change in this login scenario, we might be able to give you the list of affected test cases or the potential failures upfront. You don't need to actually execute the entire test suite or test plan to understand or to get all the failed test cases. And also the last but not the least, the image comparison that we have talked about. A Testsigma also has the similar image comparison techniques that the Apply tools has. You can compare these images by pixel, or you can mark what you want to compare and what you want to ignore, and all that can be done using Testsigma also. So these are some of the like areas where we use AI, and I really don't want to touch upon the other features that we have. And if anybody else in this group or audience list is interested to explore the tool, yeah, feel free to go ahead and register with us for a free trial. It's all open for everyone. Yeah, so there was one question: shall we get a trial version of Testsigma? Yes, there is. As I said, like it's all open for everyone. You could just go ahead and register with us through our website. Over to you, Vipul. That's all I wanted to share with you.
Okay, thank you so much, Kare. Let's talk about, there are a few other tools. Test.ai is a very interesting tool. I just talk our company. I'll just talk about it, that it uses reinforcement learning, goes through various screens and so on, and it identifies the buttons and drop downs and text boxes and so on and so forth, and then what are the right paths and wrong paths, and then it is able to basically do testing on its own. So the idea is, for most tests you don't need human beings. So is it end of manual testing? That's the question. I'm not going to answer that question, except saying that think deeply about it. Maybe, maybe not. You have to understand when and when it is not. We have a for the certification that I talked about, there is a registration link available, which is, and we have a 3-day hands-on session starting 17th of July. So if you want to register for it, you can go to bit.ly AIU online, and that should help you get all the information. I'm open for questions. Go ahead, please. I guess that should be possible. Yes, getting the recording of the session. Question by Sanchit. AI-based tool for defect prediction. I'm not aware of such tools that exist. Different companies, based on their own data, they create the tools, because such a tool would require certain amount of commonality in the data that is captured and so on. Every company captures different type of data and so on, or it would need to have certain type of data. So I'm not really aware of any such tool. How is AI helpful in banking and insurance? Lot of different ways. By identifying biases in the insurance, for example, by doing, for example, for your patterns in spending in banking and so on, it can actually help you produce better reports and so on. So there are many use cases for insurance and banking where it can be used. Can we run only those tests which are impacted due to code changes, and any tool for this area? So the interesting part is that, the impact analysis has been the holy grail for a lot of these things. Maybe KR has some interesting insights to share. Go ahead, KR. Maybe I can unmute you. Where is my, yeah, go ahead, please. I'm sorry. The UI is a little time taking, so go ahead, you are.
Yeah, so there are a few tools, like Testsigma is also one of them. I really don't want to push Testsigma here, but so you can try our own the Testsigma, just in case if you want to understand how it works. So we use some of these AI techniques that Vipul has discussed now to understand and like as I said, like the affected areas and affected tests can be pulled up automatically using. So there are a few things, like one, we have a data about your tests, on how your tests are built, the entire for the entire application. I mean, again, like this, assuming that you have automated the entire application. If you have only 2-3 tests, and I mean, we will not be able to give you the tests that were not part of this system already. So let's say you have the entire suite covered within Testsigma, then we can give you, Testsigma will give you a list of tests that are affected for any particular change in any of the screens that's already part of this test cases or the test scenarios. There are two ways. One, we understand this with the data that you provide as part of test authoring. And two, we understand the relationship between these scenarios and the user journeys or user flows while you run these test cases. So assume that you run one test case and it ends at a point A, and then you have another set of tests, another test case which starts from B. We will be able to understand, okay, where this test ends and where this test starts, and if there is any relationship between these two, a starting point and ending point, and we'll try to correlate, and then we'll mark that as a integrated test or the continued like the tests that are like interlinked or dependent. So using some of these techniques, I mean, again, like as Will said, like we still need a lot of data to, improve on this area. But with whatever we have, we're trying to do our best, give you the best results in terms of identifying this affected tests. Hope that answers your question.
Thank you, KR. You know, if there's a code change that has happened which has no apparent GUI change, for example, in that case, would your tool be able to do something, or?
Yes, as I said, like the UI change is one of the aspects that we look at, but the internal changes is also the other thing that we understand. Like, so not just the GUI changes.
Wonderful.
So GUI changes, like it's a different part. Like we identify the potential or the affected tests the GUI. I mean, using the input that user provides, and the other area that as I said, like using the run results in the previous runs, and all this is a backend. I mean, irrespective of the GUI changes.
Yeah. So I hope, Vishal, your question got answered.
Yes, yeah. So yes, Vishal, yeah, that's what I was talking. For example, from a regression suite, X number of tests to run.
Perfect.
Not the whole regression suite. Yes, so you can run a part of the regression suite, and we'll help you with that list of tests that you need to run for any change in any of those, in one particular screen.
Excellent. Any other question that you might have? How do we start integrating AI in existing test automation framework? Okay. So I'll give you an example of, let's say you have Selenium tests and you want to put AI into your Selenium tests. It's been a couple of, maybe a month or two since I have not really looked into it. But last I looked at it, there wasn't really anything available for Selenium. However, Appium had an AI library available, and you could use that library with Selenium as well. And then, you know, so essentially you include those libraries in your tests, and then make those minimal changes that are required to be done to your code. And then, you know, you should be able to do things. There may be some sort of tools available to migrate, for example, your Selenium tests to those tools which work on top of Selenium to do that kind of an activity. So I'm not sure if Testsigma, for example, has such a capability of converting existing tests into AI-enabled tests for Testsigma, but that's a possibility.
So we do support Selenium import, but and again, we need some time to understand your scripts, and then we have custom plugin a model where we understand your scripts and where we can apply AI. To begin with, from the day one, we may not be able to use AI in your Selenium scripts that you're going to import. But eventually, yes, as we understand more, like as you run the same test more like number of times, we'll be able to use this logic, as I said, like to identify potential failures.
Understood.
At least to begin with.
Thank you. I'll try to answer some of the questions that are on the chat right now. How can an AI platform infrastructure be leveraged for performance testing practice? I haven't really looked into performance testing and tools that help you, AI that helps you do performance testing. So unfortunately, I won't be able to answer that question. So if somebody else has an answer to that question, I'd be happy to know. And never looked into it. Can it be used? Certainly, because if you can feed in the kind of models, usage models that we're talking about in performance testing, then, and also the logs. So log analyzers, AI-based log analyzers, and can together with this be used to trigger various types of tests and figure out if the tests were okay, pass, fail, and so on. Guidance for beginners to learn AI who have only manual testing experience. While it looks like I'm plugging in the course, but this course is the 3-day course that I talked about is a really good way to learn things very quickly. And after that, you basically need to start learning things on your own. Pick up Python, for example. Do, if possible, look at a little bit of code, not too much, on how AI gets implemented and so on. And then look at open source AI applications and start testing them. So that's how you can, and of course, linguistic analysis method, which will help you think deeper about various data types and what all can be done. So right at the stage when data is collected, if you have already applied linguistic analysis method, you would be able to see whether there is sufficient data or not for the training, and also from the testing purpose, you can then really take a look at it. And then what will be testing scope for AI in big MNC companies? Well, everywhere AI testing is going to increase and increase and increase. So then the question about AI in testing in 2-3 years, I see this going to increase and increase. In a lot of different, all it requires is data. Unfortunately, most companies keep their data to themselves. If there is a way to anonymize the data and make it available as a public data set, then it will actually make the whole process of application of AI in SDLC much faster. AI definitely has human in future, because you are not going to depend on AI as the final thing, especially life, mission critical, and so on. So essentially what you're going to do is have human beings sitting on top. And then, of course, you still need people to look at bias and so on. AI cannot detect its own bias all the time. So you need still human beings, and who's going to write those algorithms and do this research and doing and figuring out new algorithms. So definitely for next 15, 20, 30 years, I see a lot of human beings being involved. At some point of time, when you achieve general AI, then of course, human future would be in creativity, in entertainment, in human to human connection. That's what I see. If you have any other question, I'd be happy to answer. Otherwise, I'm done.
Sir, can you give some tips to the testers? What should they do to stay relevant, and some quick things they can start doing?
Okay. Stand and die, move and live. It doesn't mean you switch companies. I'm not asking you to move companies. By stand and die, we mean knowledge. Knowledge is changing at such a fast pace. You need to understand your strengths and weaknesses. For example, you may, while this is a very generic statement, so you might feel unhappy with generic statements. So I'll try to pepper them with specific examples. Let's say I'm very good with domain knowledge, but I'm not good in programming. So what should I do? So pick up just enough technology so that you understand what people are talking about, but try to understand the relevance of your domain and gain deeper knowledge, deeper experience, deeper expertise there. Try to find patterns within the applicability of that knowledge within your domain, which will write them down, that these are the common things that happen and so on. So you continue to gain better and better domain knowledge in this case, and then start applying. So you'll have to learn technology. Which technology? Testing technology. Just the domain knowledge may not be good enough. So learn testing technology and then start applying your domain knowledge, for example, to various open source or wherever you can get a chance to apply them. Hone your skills to find bugs faster and deeper than which may not be possible by others to find. As time goes by, as a tester, you want to progress in your career. You want your salaries to increase. If a fresher can find the same type of bugs that you are finding after 6 years of experience and maybe 3 times the salary, then why should I be interested in you? So improve that. Improve your skills, communication skills, because many problems are caused by communication. Improve your time management skills. Even if you find the same type of bugs, but you find them at 1/6 the time, so you are still 2 times more effective than a fresher per bug, cost of per bug, right? So you need to basically start looking into that. If you think you're good with technology, try to learn more about technology and see how that technology can be used in testing, or how you are going to be impacted by that technology. For example, cloud. So if migration to cloud is going to happen, what can I do to learn about that? Can I create my own test account on Amazon, for example, and have an open source project and try to migrate it, or have somebody who has already migrated and then try to learn migration testing on cloud, or try to learn more about cloud, for example. Same goes for AI and so on. So you have to be in constant touch with the market and technology and what is emerging and what impact does it have on you. Development and has become a big thing for next 5-6 years. I see companies demanding more and more testers do more and more coding for automation, for static analysis, for DevOps, for dynamic analysis, and so on. Learn more about CI/CD and DevOps. Very important, and it's easy to gather this information. Of course, I'll just plug in what we do. We have a DevOps United certification also. 2-day, 3-day kind of a thing, which tells people how to basically test in this environment. So it gives you a good start. And after that, you have to practice on your own to see how these can be done. So pick up a programming language, scripting language, maybe Python, maybe JavaScript. Pick up a tool, automation tool. See which are the, not necessarily Selenium, but there are a lot of new ones. So basically expand your horizon, expand your knowledge. And when that happens, read people's blogs and posts, think, and automatically you will gain better knowledge. You will understand what paths now you need to follow. I'll give you one last tip. Read bugs created by other people and ask yourself, if I were writing test cases, would I be able to write a test case which will catch this kind of a bug? Or what kind of testing do I need to do? So read a lot of bugs, critical bugs especially, raised by other people, and try to ask yourself, how would I catch this kind of a bug? Do that exercise for 1 month, your testing will improve by itself. Anybody else has any question, feel free to ask. Not, thank you so much. Do I know of any blogs such? Very hard, okay, from an AI and testing perspective, Jason Arbon, I'm writing the name. So there are other people also, Tariq King, but Jason Arbon is one of the best persons in the field of AI and testing. He's the owner of test.ai, and He's former Google, and he has participated in that book, co-author of the book, How We Test Software at Google and so on. Really nice guy. Okay, so that's it from my side then. Over to you, Shruti.
Yes, thank you, sir. So I think we can close then if anyone does not have any questions. We'll be sending the recordings in the email.
Pleasure. Thank you so much. Namaskar.
Thank you.
Thank you, guys. Thanks, Vipul.
Right.
See you.
Pleasure, and thank you for giving me this opportunity, Testsigma. Look forward to do more of these things.